So in this video, what I wanted to go over were a few things that are important to know about reading histograms. And really the biggest thing about reading histograms that's a little bit different than reading standard bar charts is that you'll notice that when you look at a histogram, you'll see that there's no gaps along the x-axis. And that's very, very important to realize that basically all of these bars that are within this histogram have a common width. And that width is something that's referred to as the bin size. So what a bin is referring to here is the idea that each of these bars are not a standard bar like on a traditional bar graph, but instead they range over a certain set of numbers. So if we were to actually label each of the bins here and talk about them as if they were first bin, second bin, and third bin, this would be bin number 1, bin number 2, 3, 4, and 5. Out of these 5 bins, we could write the range that they cover by looking at the numbers along the x-axis. And that's very important to remember, is that you are always looking at the x-axis when talking about the bin range. What makes this kind of confusing is that if you were to read this first bar, which is the number of people that had composite ACT scores of a certain range, the number of people that had scores ranging from 10 to 15 would be a total of 4 people. Now, that seems like it might be a little misleading when you look at it, because what if I ask the question, how many people had a range of 15 to 20? Well, you can see looking at this, the range from 15 to 20 is 7 people. But here's my question. Let's assume that there were all these people that took the exam and they all scored a 15. Would those people be counted in bin number 2, or would they instead be counted in bin number 1? So let's take a look at this here for a second and say, okay, let's imagine I have the scores of 7, 8, 10, and 14, and 15 as well. The idea here is that, well, we can clearly see, as far as bin number 1 is concerned, 7, 8 would not go in that bin. So we could just clearly cross those out. The number 10 clearly would go in bin number 1. So what you would get would be the idea that you would have 10 to 15 right here as the bin, and then the number 10 would be floating around as just a little counting chip. Well, then we get to 14 right here, and 14 would go into that bin. But now we get to 15, and the question is does 15 belong in this bin, or does it really belong in the next bin? Because if you think about the next bin, the idea is that it could be 15 to 20. Well, if we counted 15 inside of both bins, then what we would get would actually be one bar that said that we had 3 scores, and then another bar that would say we had 1 score, which means that there were 4 scores that were actually counted in the histogram. But if you look up here, there's only 3 scores that we actually dropped into any bin. So we can't really say that the scoring range is from 10 to 15. So this is the first key thing about histograms that's a little confusing, but once you get used to it, it's really easy to understand, is that the range that any bin covers will always be from the start up to, but not including, the right-hand numbers. So bin number 1 will include all of the scores that are from 10 up to 15, but not including it. And if I had to write an inequality that would talk about that, it would look something like this right here, where we could say that any score along the x-axis that's between 10 and 15, it can include 10, but cannot include 15. Likewise, looking at bin number 2, we can say that that scoring range is from 15 up to 20, but not including it. So we would say that it's 15, bin number 2 is from 15 up to, but not including 20, and x could be any number between them. So it would look like 15 is less than or equal to x is less than 20. And then you could do that for each of the remaining bins as well. Now, what we've just done here is we've looked at what a bin is. The bin itself is actually the range of numbers, so the 10 to 15 range, the 15 to 20 range. But the interval is talking about the idea of, can it be included, can it not be included? The important thing to also recognize is that there's a width that's associated with each of these bars. So if we look at the width of bin number 1 from 10 to 15, we would say that this has a width of 5. Bin number 2 has a width of 5. So we could say that this has a width of 5. This also has a width of 5. Looking at bin number 3, I can see that it has a width of 5. And then bin number 4 has a width of 5 as well. And you might think to yourself, well, that's not very common. One of the rules about a histogram is that each bin must have the same width in terms of its intervals. Once the intervals have been created, the thing to remember is that while you're reading them, you always would include the starting number in the bin, but you would have to say you go up to, but not including the final number right here. So writing bin number 5 as an interval, we're going to say that we can start at 30, go up to but not include 35, so it would look like this right here. Basically, the idea is to remember that you're always having to think about what numbers would go where. So in answering some of your questions on exams, such as how many people could have the score 17? Well, thinking about where the score 17 would fall in here, I would say that the score 17 would fall somewhere around here. Well, looking at what could happen here, I don't know the exact number of people, but I do know that there might be no one who got 17, but I do know that there could be up to 7 people because this bar's height is 7. So there's a total of 0 to 7 people that could have gotten the score 17. Do we know the exact number? No, but we definitely know that it cannot be any more than 17. Now, if we ask the question, how many people could have gotten the score 20, the important thing to remember is that this 20 does not get counted in bin number 2. Instead, it gets counted in bin number 3. So the highest number of people that could have gotten a score of 20 would have been 9 people all the way up here, but it could drop all the way as low as 0 people right here because, again, we don't know the exact number of people that scored a 20. This bar only tells us how many people scored between a certain range, and 20 happens to be a part of that range. We don't know any of the other scores. As a result, you can say that you know some possibilities. You can't really say anything with certainty. Now, what we can say with some certainty about some of the other bins is that if we included scores such as 25 up to 30, then we could say, oh, a grand total of 6 people scored between 25 and 30, or we could say 6 people scored greater than or equal to 25, but less than a 30. So we could say that that would include our 29s, 29s and a halves. Unfortunately, on the ACT, you're not able to score a decimal, so we could just say that they would have the highest possible score of a 29 in that case. So I hope that helps to clarify how to read a little bit of your histograms. If you have any questions, by all means, feel free to leave them in the comments or send me an email, and I will get back to them as soon as I can.